So you're being asked to graph the function f of x is equal to 2 to the x power plus 3. And if you're asked to graph any function at all, whether it's a line, whether it's a whether it's an exponential function, whether it's a quadratic function, if you don't remember how to do it, or you haven't learned how to do it yet, no matter what function I give you, you can figure out the graph by doing a table of values. Okay? Now we already know that the graph of this is going to look like this, right? Where there's going to be something called an asymptote here, right? What does it mean? It's the line here that this never reaches. It just keeps getting closer and closer and closer, but never reaches it. This is sort of the border. This, on the other hand, is going to keep going up and keep getting bigger and bigger and bigger as we go further and further along. So let's see what happens here. If I put in 0, what's this going to be equal to? What is 2 to the 0 power? 1. 1 plus 3 is 4. There you go, right? Okay. And if I put in 1, it's going to be 5. And if I put in 2, it's going to be 6. Did you say 6? 7, yeah, right. And if I put in 3, what's 2 to the third? 8, right? Plus 3? 11. Okay. That should be enough points, right? Where I can now go over here and say, okay, if x is 0, y is going to be 4. If x is 1, y is going to be 5. If x is 2, y is going to be 7. And if x is 3, y is going to be 11. Okay? So we now have the shape of our curve. Over here, it's going to go straight up like that. And on this side, it's going to come down further, but never ever reach the next line. Right? In a case where we know what the curve is going to look like, right? We know that when x is less than 0, this is going to keep getting smaller and smaller and smaller, right? But never become 0. Okay? This is -1, this is 1 over 2. If it's -2, it's 1 over 2 squared. If it's -3, it's 1 over 2 to the third. It just keeps getting smaller, but it never ever reaches 0. So we know what this side of the line is going to look like. Okay?
So once you see that function, you already know how the line's going to look like?
It's an exponential function. So that's what's going on here. And on this side, we know that because it's an exponential function, it's going to go up faster and faster and faster. The only thing that's different here from the ones that we have dealt with in the past is that it's moved, right, 3 up from where it normally would be. What they call the parent function, right? If I just had like that would be down here. Right? And this side would go down like this, closer and closer. Sorry. And for every one of these points, this is going to be 3 higher, 3 more. Because whatever this is, I'm going to add 3. Okay? These drawings, these equations, and the stories that go with them, okay, they all should come out to the same thing. They should all make the same kind of sense. They're the same story. Any questions about that? Okay. So Write the first 4 terms of the sequence described by the recursive formula. Well, the first term is 3. Okay? Now, in order to get the next term, okay, I have to take the term that comes before, which in this case is 3, and I have to multiply it by 2. 6. Now I have to take the term that comes before, multiply it by 2. Now I have to take the term that came before and multiply it by 2. Right, and if you started one more than that, right, this would be 48 would be over here. Okay? Now, what kind of sequence is this? So what you want to tell me is that it's a geometric sequence, and the common factor, right, is 2. Right? And the fact that if you use the word factor, then I know that that means you recognize that this is multiplication. Okay? If you don't remember the term factor, you can just tell me I'm multiplying by 2 each time. That would be okay too. Then write an explicit formula. Okay, so what's going on here? Well, I'm starting with 3. Okay, so when x is equal to 1, f of x is equal to 3. Then the next time it's equal to 6, so when it's 2, rather the second term, I'm going to be multiplying by 2. So I didn't multiply the first time. I did multiply once the second time. I'm going to multiply twice for the third time. Guess what? And that would be the explicit formula. Okay. Okay. Questions about that one? No. On this side, we're looking at a sequence that is -14, -8, -2, +4. What kind of sequence is that? What kind? Arithmetic. And how do you know? Right. It's adding 6 each time. Right? And that means that the common difference, that's the word the phrase we use for this, the common difference is 6. Okay? That's what you needed to put down here. It's an arithmetic sequence. And we know that because we're adding 6 each time. Now, if you're writing an explicit formula for that, well, what does that mean? Well, for the first one, I started out with -14. Okay? And for each one after that, I added 6, but I didn't do it the first time. And I only did it once the second time. And I only did it twice the third time. So for each term, I'm going to add 6, one less than the number of the term it is. Yeah. Oh, yeah, I'm sorry. Now, with both of these, right, the idea here is you should be able to plug in, right? You should be able to plug in whatever term this is. So here, this is the first term, second term, third term, fourth term. Let's take 4 and plug it in for x and see what we get, right? F of 4 is going to be -14 plus 6 times 4 minus 1, right? -14 plus 6 times 3, -14 plus 18, +4. And sure enough, if you don't get the same answer, something's wrong. Okay? Okay. Let's go back here for a minute. All right. Here's term 1, here's term 2, here's term 3, here's term 4. Okay? Let's plug in 4 for x and see what happens. Just to double check. 3 times 2 to the 4 minus 1 power. That's 3 times 2 to the 3rd power. All right? Yeah. That's 3 times 8. That's 24. And yes, that worked. We've got a good formula. If you write a formula and you can't then take it, plug in the number, the index of the term, so the first term, the second term, the third term, that's called the index. Okay. This part right here, this part right here is called the index of the term. Basically, it's like a name tag. And what that means is if I want the 4th term or the 5th term, or in this case, the 27th term of the sequence, which is what that asked for, I need to be able to plug 27 in to my equation to get the answer. So, 27th term, let's see. F of 27 is equal to negative 14 plus 6 times 27 minus 1. Right, that's negative 14 plus 6 times 26. That's negative 14 plus 156. Okay. Sorry. And so now we have to subtract this, so it's going to be 142. And that's going to be f of 27, or the 27th term.